channel Success Engineering Official. Today we are going to learn kitchen ventilation designing and drafting. So as you can see here, this is one simple kitchen plan. We will do the designing as well as drafting. So let me open this tutorial first for designing tutorial. So as you can see here, this is kitchen ventilation design. Okay. As you can see here, this is an important point to be considered for kitchen ventilation. First one, exhaust or makeup air flow rate, flow velocity, 1500 to 2200 feet per minute. Duct velocity as per NFPA. As per NFPA, National Fire Protection Association, the velocity of kitchen duct should be 1500 to 2200 feet per minute. Duct to be terminated 40 inch above the roof. For example, your duct is going and passing through the roof from the kitchen and it is going to the roof. So duct is terminated 40 inch 1 meter from the roof. Okay, and clean out to be provided at the base of the riser and every 20 feet. There should be clean out also provided on the duct and the clean out duct riser, and it should be at every 20 feet. And duct seat, and next point is you can see here duct seat metal gauge should be 16 gauge. Okay, 16 gauge galvanized steel or 18 gauge 304 stainless steel. It is about materials of the duct. It should be galvanized or SS 304, but 16 gauge to 18 gauge. Okay, and hood construction should be 18 gauge minimum. The hood size. The material of the hood should be 18 gauge minimum. Okay, and black steel duct is used for laundry exhaust. If there is laundry exhaust, then the black steel duct should be used. Okay. Next is kitchen ventilation design consideration: hood size, then duct size, then exhaust airflow calculation. Okay. The types of hood, there are three types of hoods are there. Type 1 is used for removing a smoke, grease, used for cooking appliance. Type 2 is used for the steam, vapor, heat, odors where grease is not present. Use dishwater steam. Next is there are three types of hoods are there: wall canopy hood, single island, and double island. I will show you how it looks like. So let me open this, go to the file, and I will show you. This is the single island hood. Okay, this is the single island hood. Okay, and this is the wall canopy hood. This is used for commercial building, hotel and commercial hotels and all. This is for the mostly for residential and offices. This is called wall canopy hood. Okay, and this is called double island. In this is double island. Okay, double island is nothing but this is the single island only, but the hood is two, so both side the single hood is used in each side is called double island. This side is also kitchen and this side is also kitchen. This is mostly for commercial building, commercial hotels. This double island hood is going to be used. So we will design the duct and hood size and all. Okay, in this tutorials. So this is the types of hood actually. Okay, so next is exhaust air CFM. So how to calculate the exhaust air CFM? You have to design, you have to calculate the exhaust airflow to from the kitchen. How much will be the exhaust? Exhaust air CFM is equal to P into linear length. P is nothing but the perimeter in feet. Okay, the perimeter in feet, perimeter of food in feet, and linear length. Okay, so linear length. So P is equal to 2L plus W for wall canopy hood. If there is wall canopy hood, then for to find out the P, you have to use this formula P is equal to 2L plus W, where L is the length of the hood and W is the width of the hood. Okay, then you can find the found the P from here and put the P here, and linear length is nothing but this has been taken from here. It will depend as per exhaust flow rate category table. I'll show you. Okay, so minimum exhaust flow rate CFM per linear feet of hood length, and this is linear meter of hood length. This is in meter, and this is the maximum, this is the minimum. Okay, so feet of the hood length. So this is you can see here there are types of hoods: wall canopy, single island, double island, and this is the uses. Okay, this light duty, medium duty, heavy duty, extra duty. So if there is a wall canopy hood, for example, if there is wall canopy hood and the usage is light usage, usage in the sense is nothing but this is for the commercial. Medium usage is nothing but the residential, and heavy usage is nothing but the industrial and hotel. Okay, so if there is light usage and hood type is wall canopy, so you can use this one, this value, okay, 140 for the linear feet, maximum linear feet of hood length. Okay, and also here given this is the minimum exhaust flow rate by equipment CFM per linear meter of hood length. So if there is wall canopy and the usage is medium, then you can use this one, 90 feet. Okay, so we'll use this value. Okay, so next P is equal to 2L plus 2W for single island. If the hood type is single island hood, then use this formula P is equal to 2L plus 2W to find out the P value, and put this P value here and multiply with linear length, then you will get the exhaust flow. Okay, and next one is P is equal to 2 times of 2L plus 2W is nothing but for the double island. Double island is nothing but you have to simply multiply into 2 with the formula of single island. Okay, so next see one example. A kitchen, an example here given. A kitchen have a stove size of length is given, length of the stove is given 800 mm and width is 400 mm. Calculate the exhaust air flow in CFM and duct size for wall canopy hood. Okay, so this is your formula and this is your example. So the you can give here, this is given, you can see this is given, length of the stove is a small n, I am considering a small l, 800 mm, and width of stove is given also 400 mm. So length of the hood, so how to calculate the hood size? For the hood size, whatever the stove size, you have to add the 50 mm, 150 mm each side. Okay, so length of the hood will be L plus 150 plus 150, because this is a wall canopy, so there are 3 sides only. Okay, so because of wall canopy there are 3 sides, you should add 150 mm each sides. Add this one L plus. Okay, here it should be plus 150 more because there are 3 sides for wall canopy. Okay, so length of the stove is 800 mm given and width is 400 given, so length of the hood will be L plus 150 plus 150 plus 150 because of wall canopy hood, because one side is fixed in the wall and 3 side is exposed, so you have to consider 3 150 150 plus 150 plus 150. Okay, and again here will be 150. Okay, so total how much? 150 150 150 150 into 3 plus 800. 800 is nothing but length of the hood. No, it's wrong actually. We are calculating the length of the hood, so you have to multiply when the length is nothing but only 2 sides. Okay, so two sides, and if you are calculating the width, then you one side, so it will be three sides. It is only two sides, because in the length wise you have to, for example, this is the length. Okay, I will show you here. Wall canopy wood. This is wall canopy wood. Okay, let me open this. Okay, so this is wood, wall canopy wood. So we are calculating the size of the length. Okay, so size of the length of the stove and width of the stove is given. For example, here this is wall canopy hood. Okay, so this, in this drawing you can see this is the stove. So this is the length and this is the width, and this is wall canopy. So one side, this side is fixed in the wall. So once you are calculating the length of the hood, you have two sides only in the length. Okay, this side and this side. So you have to add a 150 in each side, 150, 150. So here will be your 150 only, 150. Here is 150 length plus 150, 150. Okay, so it's fine. 1100. Total length of the hood will be length of the stove plus 150 each side, so it will be 1100. And width, now we are going to calculate the width. So to calculate the width of the stove plus 150, because if you see here in this drawing, let me show you here. So this is the width. Width is nothing but this side is fixed in the wall, so you have to add only one side, this side only. So 150. Here W plus 150. W is nothing but the width of the stove, so 400 plus 150, 500. Okay, so now you have to calculate the P. P is equal to 2L plus 2W. 2L plus W is for wall canopy wood. So 2 into L. L is nothing but the length of the wood, 1100 you already found here. Here 1100 plus 550 is nothing but the width. Okay, so 2200 multiply this one, 2 into 1100, 2200 plus 550. It will be 2750 mm. Okay, so this is the P in mm, so you have to convert into the feet. So 1 feet is equal to how much mm? 1 feet is equal to 12 inch and 1 inch is equal to 25 mm. Okay, so 300 mm. What you will do, simply divide it by 3. 2750 divide into 300, so 9.16 feet. Okay, so approximate you have to consider 9 feet. Now you have to calculate the exhaust flow CFM. P into linear length. So P into 210 coming from where? 210 is coming from here. The maximum exhaust flow rate CFM per linear feet of wood length. So for the I am considering this is the uses as a medium uses. So for the medium uses, for wall canopy wood, the medium uses, the linear length is 210 feet in the feet. That's why I am converting this into the feet, P perimeter, because this value is given here in the feet. So P into linear length. So P is nothing but the 9 into 210. So you are getting 1890 cfm. Okay, and linear length of the wood 210 for the medium usage, as you can see here, and 140 for the light usage and 280 for heavy uses. Next, we have to calculate the duct size for rectangular duct. So Q is equal to A into V, continuity equation, you know, as you know, Q is equal to A into V. So A is equal to Q by V. So A is nothing but the Q you get already 1890, and V we considering 18 feet, as I told you in the beginning, 1800 to 2200 feet per minute velocity consider for the kitchen exhaust design. So after divided this 1890 divided by 1800, we are getting 1.05 square feet. Nothing but the area. Okay, and the area is called W width into height. Area is nothing but the width into height is equal to 1.05, and we assuming the height of the duct is 0.5 feet, that is nothing but 150 mm. So you can get the width as well here. Okay, so simply 1.05 divided by 0.5 is nothing but the height. Simply cross multiplication here I am doing. So I am getting 2.1 is nothing but the width. Okay, so height we assume and we get the width, or or you can calculate the duct size from the duct sizer also. Let me open this, I will show you here. Okay, so flow rate is how much? Flow rate is 1890. Okay, and velocity, so check here flow rate and velocity. So velocity is 1800. Okay, then you will get the, simply change the unit from here. Okay, now this duct size in mm. So height we assume 150, then we are getting 825. This is the exact actually. This duct sizer is more accurate. We are getting this 825. Okay, the width. So the width of the duct will be 825, is nothing but the 800 only. Okay, always consider the even value, so and higher value. So 850, 150 by 850. Okay, where V is equal to 1500 feet for the medium feet, 1500 feet per minute for medium uses, and 1800 feet per minute for heavy uses. Okay, and ER is nothing but the aspect ratio, so you should check the aspect ratio as well here. So you get already here 150. So aspect ratio is nothing but the bigger size of the duct divided by a smaller size of the duct. So we are getting 850 divided by 150. Aspect ratio should be 4:1. So once we calculating with the duct size, your aspect ratio is not matching. That means what you will do, you have to increase the height of the duct. For example, we are considering 200 height of the duct. Now again you get here 550 width. Now we have to check again the aspect ratio. So 550 divided by 200, 2.7 is in the range 4:1. Aspect ratio is always 4:1 to reduce the running cost of the project, frictional losses. Okay, so we are getting 2.75. That means you need to change here. You need to change here your duct size. Here from the duct size here 200 is we assume, and here will be your 550. So aspect ratio is 550 by 200. Aspect ratio will be 2.75. Here 4.3 is the greater, so we cannot consider this tag, because once we consider 150, then it was 4.3, so we not consider. Okay, let's go with the same example. Then next we will see. Okay, so after assuming the 150 height and the width, we getting 650. So check here aspect ratio. 650 divided by 150, so 4.3. So 4.3 is greater than 4, so we cannot consider this duct. Okay, aspect ratio should be 4:1. So in the next slide, show change the height of the duct. So now we are assuming the different height. Other height 0.8 feet is nothing but 250. After 250 height, you have to calculate the width again. Okay, so simply divide 1.05 is nothing but the area. 1.05 divided by 0.8 feet. So 1.3 feet convert into the mm. Simply multiply into 304. Okay, so you are getting 399 is nothing but the 400. 1 feet is equal to 304.8 mm. Okay, you are getting 400 mm. And aspect ratio, again check the aspect ratio. So your height will be 250.8 feet is nothing but simply multiply into 304.8 mm. 1 feet is equal to 304. So 240 approximate we consider 250. Because of this, duct is always considered the duct size even value as well as even value. Okay, and even and okay, even value. Okay, so 250 is the height now, and the width we are getting 400. So now you have to check the aspect ratio again. The bigger size of the duct divided by 250, a smaller size. 1.6 we are getting. That means 1.6 is less than equal to 4, so 1 is to 4. So we can consider this type of duct. That means your aspect ratio should be 1 is to 4. For the round duct, you know already the area of the circle is pi d square by 4, so you can calculate the diameter of the duct from this formula. So what you will do, simply pi d square by 4. From this formula you can cross multiply. So you take this d here, and if you simply take the d, then you square root will go to here, under root. Okay, so this is simply a simple calculation. So d is equal to root under 4 into a by pi. 4 into 1.0, a is nothing but 1.0, and divided by pi. The value of pi will be 3.14, as you know. We are getting 1.15 feet and convert into the mm. So 350 mm is the round duct size. Okay. Next is types of exhaust fan. So you can see here the centrifugal fan airflow is perpendicular to the impeller rotation. Centrifugal fan is how you identify the centrifugal fan. The fan which is the flow of the fan is perpendicular to the impeller rotation. Axial fan, the flow of the fan is parallel to the axis of the fan impeller. Power roof ventilator, a blast fan, and tubular centrifugal fan is nothing but the inline fan. And then you have to select the fan, calculate the ESP. Okay, and next is thanks for watching. Please like, share, and subscribe my channel, and hit the bell icon as well to get the notification of my upcoming videos. Okay, so next tutorial we will do the drafting part. This is drafting. So now thanks for watching my video. Thank you, bye bye, and don't forget to watch my next tutorial for drafting, kitchen ventilation drafting. So thanks once again. Thank you, bye bye.